We'll be discussing how to convert a Python 2 application or library to Python 3. The library we'll be working with today is DeLorean, a datetime library that I wrote in Python 2.7, which should support Python 2.6 and up to Python 3.2. As you can see here, there are tests failing for Python 2.6 as well as Python 3.2. So today we'll be going about and discussing different ways to convert your application to be runnable on all versions of Python. I will also talk about a few things that you may want to be aware of when converting from Python 2 to Python 3, as well as some migration strategies for taking your libraries and converting them and providing them for people who use Python 3 and for Python 2. Before we start converting DeLorean, let's first take a look at the things we'll see when dealing with code in Python 3. As you can see here, I have two interpreters, one with Python 2.7.2 and Python 3.2. If you are currently using Python 2.7, a lot of these idioms or ways of writing particular pieces of code have been backported into Python 2.7.2. So some of the things I may show you, you may seem to think that they work in 2.7, but that's only because they've been moved backwards. I will first show you the way of doing it in traditional Python 2, and then I'll show you that it doesn't work in 3.2 and how to fix it. So let's first take the simplest statement that we can think of, which is the print statement. In Python 2, you can simply do things like print 5 and print dog without much trouble. Now, when you try to do the same thing in Python 3, you get an error. You can't print 5, and you definitely can't print dog. In order to combat this and fix it in Python 3, you need to do this, because the print statement was converted into a function, so you have to call it with arguments, as you see here, and the same thing with dog. Now, another thing that's been combined in Python 3 is longs. There's no such thing as a long anymore in Python 3, so you were able to do this before and get a long back. And in Python 3, there is no such thing as long, so when you do this, you get long is undefined, there's no such thing. In order to combat this, you do assign long to int, and you go long, whatever number you want, and then that's how you do it. And long syntax combined. So before you run anything in Python 3.2 using longs, you just convert the meaning of long, or you assign long a meaning. Since Python 3.2, it doesn't exist. Now let's try something that's a bit more involved. Let's try dividing by 0 and then catching that exception. So in Python 3, in order to do such a thing, you'd simply divide by 0. Divide by 0, except that 0 division error, e colon, 1, 2, 3, 4, print e.args, and we want the first argument printed back out to us. And as you can see, interdivision or modulo by 0, exception. And we got the print to come out, no problem. So let's try the similar thing in Python 3. Try for 1 divided by 0, except 0 division error, comma e colon, and that gives us a syntax error. So the proper way of doing this in Python 3 is try 1, 2, 3, 4, 1 divided by 0, except 0 division as error as e, 1, 2, 3, 4. Now, when we're printing, we have to be careful to use the function, so we will do this, args 0. Oh, we need the closing brace there. And then we get the exception division by 0. So that's just to show that there's a lot of subtleties when going from Python 2 to Python 3. And there are a lot of libraries we'll cover today when discussing how to convert DeLorean from Python 2 to 3. So let's go back to Travis and see what the issues are that we're seeing when building against Python 2.3 and 2.6. So we'll first take a look at 2.6 and see what could be the problem. So this shows us the build output from Travis while building and testing our DeLorean package. As you can see, it installs fine without much issue. The tests run and we have one exception. It says that the datetime delta object has no attribute total seconds. That is interesting. So this likely means that total seconds was introduced in Python 2.7 and is not available in Python 2.6. So we can easily solve the issue here, and let's take a look at it real fast in the source code. So let's open up that particular test. You can see here it's epoch test that was failing. and it's simply saying to get the epoch time and assert that. So the method we want to look at is the epoch and dates module. Excellent. So this is the portion of the test that is failing, and this apparently isn't available in Python 2.6. So we can easily fix this issue, and I believe this is the only place that we use total seconds. Let's just take a look here. Yeah, this is the only place. So we can easily rework this to make it compatible with 2.6. So all we need to do is write a function to get total seconds that takes a time delta and returns the number of seconds that it represents. So let's just quickly just write out a doc string for this so we know in the future what it does. I tend to forget what methods I wrote yesterday do. So let's just simply say this method takes a time delta and returns the number of seconds it represents with the resolution of 10 to the 6. Awesome. So let's return. Now we all know that, or hopefully we all know, that time deltas have seconds, milliseconds, and days attributes, which they use to represent the time difference between two date times. So in order to get the total number of seconds, we have to add those all up together. So let's first deal with the microseconds. So td.microseconds plus, we then have td.seconds plus td.days times 24 hours in a day and 3,600 seconds in an hour. Then multiplied by 1 to the e of 6, then divided again by 1 e to the 6. And that should provide us with the same functionality that the total seconds did. So we'll simply rewrite this so that it takes the delta as an argument, get total second, and we'll pass delta in, and beautiful. So let's make sure that actually works. Let's run our tests here. Make test. We have an issue here, has no attribute day. Let's go back here. I must have miswrote something here. Days is what we actually want. Let's rerun the test again. Yay, everything works. This is awesome. So when converting an application from any version of Python or anytime you're changing code and you have tests, and you should rewrite the thing that you're trying to mimic or improve and then run the tests to verify that none of the functionality has changed. So before we had a test for test epoch, it would return the correct number of total seconds since January 1970. We then realized that this wouldn't work in Python 2.6. We wrote a workaround. We used that same test that we had in the previous version to verify that we did not break any of the current functionality in the library. This helps with dealing with regressions so you don't fix something and then break something else. So I'm going to run this through Travis, and when we're back, I'll show you how everything worked, and then we'll move on to fixing Python 3.2. So by the power of movie magic, we are back. Our tests have run, and we have now Python 2.7 is all green, which is great. But the problem is that Python 3.2 is still broken. So we're going to go over a few migration strategies for going from Python 2 to Python 3. So one strategy you can take is only support Python 3. Hopefully this will happen relatively soon, but a lot of applications have been written in Python 2, and there's not a lot of force to make everybody switch to Python 3, but I believe that's starting to change now with a lot of the new functionality in Python 3. But for the most part, that isn't an option that most people can have. Another option you can do is support Python 2 and Python 3 distributions via the 2 to 3 package, which is a package that helps you convert Python 2 code to Python 3 at install time. So you can use this distribution with setup tools and distribute to convert or take your Python 2 code and on install onto a version of Python that is above Python 2.7 will convert all the code to Python 3 on the fly. So you just commit all your changes to a Python 2 version, convert it locally, make sure you run the tests so that you make sure that it actually works in Python 3 and above, and it'll do the conversion on the fly on the host computer. Or, and this is the option that I prefer if possible, to rewrite your Python 2 code so that it can both run in Python 2 and Python 3. Now, if you go back past Python 2.6, where it doesn't have a lot of the intermediary steps, for example, in Python 2.5, you can't do print like this. It just won't work. It doesn't wear. All the backports were only done up until 2.6. Now, if you're working from 2.6 and up, then this is much easier. You'll have an easier time switching from 2.6 to Python 3. and it'll be easy to do the switch over and have one code base which is compatible with two. Now, there's a lot of libraries that also help with that. There's one called 6, which will come in very handy when doing this. So what I first suggest everybody does is take their Python 2 library. Hopefully, you'll have some tests so that you know when you change stuff, it won't actually break. So your first step actually is to write tests for whatever library you're converting, just to make sure nothing breaks. Then what you do is you run them 2.3. 2.3 is available in, I believe, up until in the standard library from 2.5 and up. And what it does, it lets you run a conversion on your Python 3 code. So what we do here is, so we have DeLorean, it's right here, it's in this package. This is where all our source code is. What you do simply is go Python 2.3 -L, and that'll list out all the changes that it's supposed to do, and then we'll run that against the DeLorean library. So as you can see, it spit out all the fixers that I was running against it, and then spit out all the changes that it would need to do. Luckily, this library isn't too bad, and we can make a lot of these changes really quick. A fixer is what converts something like this. So let's just quickly take a look. So we remember, like we said before, you have Python 5 can do this. What a fixer would do is simply take the Python 2 version of your print statement and convert it in line with a Python 3 compatible version. So that's what Python 2.3 does. You can even have it so that it will write to the actual file and create backups so you can convert back to this. Or you could even have it just completely run against your whole entire code base and spit out a new one, and you can run the test that way to make sure everything works. So we ran it, and we saw that there were two changes that we need to make. We need to make that print statement here, which albeit is superfluous, but I'd like to keep it in the code base, is to simply wrap it in brackets, which takes the statement and makes it a function, as well as the Unicode method that we have here, which this function no longer exists in Python 3. The equivalent is to wrap it in a string call. So let's quickly just do that. So one's in exceptions.py and one is in interface.py. So let's first do the exceptions one. The call no longer exists, so let's just make it a string. Save that, and then we go to the interface.py. We want to go to print. There's only one print here, and simply wrap that in a function call. And that, for the most part, should be all we need to do to convert this particular library to Python 3. Let's make sure it still functions under Python 2.7. Make test. Awesome, everything still works. So we're going to push this code up and have it run against Python 2.3, and then we'll come back and we'll discuss what was the result. So we're back again, and another version of Python is supported. So this just goes to show that converting from Python 2 to Python 3 is just a matter of meticulously writing tests and then making sure those tests run in the multiple versions, and then using the tools that Python provides to help you with that conversion. Oftentimes, this will be more of a task than simply just switching around a few calls, but this goes to show the process of switching. So change some of the problems, run the tests, fix them, and then move forward that way. We also showed you a few ways about going about migrating, either completely convert to Python 3, or support both Python 2 and Python 3 using 2.3 via install through distribute, or to simply convert your source so that it runs both on Python 2 and on Python 3 without any changes. So we have one last thing to do, and that's to update the setup.py to reflect the fact that it now supports Python 3. So let's just copy this line, and this line is mainly a classifier, so when people are looking at the library, they know that it supports Python 3. And so we'll have that here, and then we'll have all the versions, which are Python 3.1, Python 3.2, and yeah, one too many we had there. And that is that. So that concludes the screencast